Lesson 6.12 is called L'Hôpital's Rule. His name kind of looks like a little hospital, so sometimes that's what we like to call it, but it's L'Hôpital. The H is silent. It was named after this French mathematician. I'm not even going to try to pronounce his full name, but he was from the late 1600s, and he found out that if you're trying to take the limit of some kind of rational function where you have something being divided by something else as x goes to a number, if you end up with an indeterminate form, which we've talked about when we get like 0 over 0, could also be infinity over infinity, but I don't think we ever see that case. But if we were to do direct substitution, plug in this number to the top and the bottom and get 0 over 0, then basically what that says is something needs to be done to this because it can't be determined yet what the limit is. But what he found out was actually if you take that same function and you take the derivative of the top and the derivative of the bottom function, then do direct substitution, that will tell you the overall limit. Okay, so let's try some. And I have to explain too that sometimes L'Hôpital's rule doesn't even work or isn't necessary. So your first job is always to do direct substitution. So number one, we have a table. The limit as x approaches 1. And so what we want to do is just direct substitute here. That would be 4 times 1 squared plus 5 over 2 times, that's f of x, so we're finding f of 1 plus 2. And so that would be 1 squared is 1 times 4 is 4 plus 5 makes 9. So already I'm seeing I'm not going to end up with that indeterminate form. So L'Hôpital's rule won't be needed. And then f of 1, that means at x is 1, what is y? So that would be negative 1. So we have 2 times negative 1 plus 2. I get 9 divided by, that would be negative 2 plus 2 is 0. It's okay to get 0 in the bottom, but what that tells me is this does not exist. There is a problem at that spot at 1, so that answer is does not exist. All right, number 2. We're going to plug in x is 2, see what happens. So this would be 2 times f of, you're going to take 2 times 2, which is going to be f of 4, minus 2 squared, over 2 times 2 squared minus 8. Okay, so 2 times f of 4 would be 2. So it would be 2 times 2, which is going to be 4 minus 4. That gets 0 on the top. And then this would be 2 squared is 4 times 2 is 8 minus 8, which is 0. So since this is indeterminate form, then we need to use L'Hôpital's rule. And so I don't get all fancy and write it. I just go ahead and take the derivative of the top. And so this is going to be a chain rule here, where it's going to be the derivative. So it'll be 2 times the derivative of f. Keep the inside the same, but then times the derivative of the inside is times 2. I'm going to float that in front. Minus, that'll be 2x. So that's on top. Over, that'll be 4x, and the constant goes away. Okay, now I'm going to do direct substitution and plug in x is 2. So it'll be 2 times 2 is 4. This will be taking f prime, or the slope at 2 times 2 is 4, minus 2 times 2 is 4, over 4 times 2 is 8. F prime at 4, so find x is 4, go all the way over to the last column, that's 6. So we got 4 times 6 minus 4 over 8. That would be 24 minus 4 is 20 over 8, which can reduce, divide by 4, would be 5 halves. All right, number 3. First try direct substitution. We have a graph this time. So we'd have 3 times negative 2 is negative 6 plus 6 is 0. We have 3 times negative 2 is f of negative 6 minus negative 2 would turn into plus 2. So go over to your graph. This is saying when x is negative 6, that would be the point right here. We see that it's a y value of negative 1. So we have 2 times negative 1, which is negative 2 plus 2 is 0. So we do get indeterminate form. L'Hôpital's rule could be used. Derivative of the top is easy. It's just 3. Derivative of the bottom, since I know I'm going to have chain rule, that 3 is going to have to get multiplied by the 2 in front, so it'd be 6 times f prime of 3x minus derivative of x is 1. Okay, now do your direct substitution. 3 times negative 2 would be negative 6 minus 1. So I'm trying to find the slope at negative 6. So that would be this piece right here. That's linear. What is that slope? Well, I see a point here and a point here. It goes down 1, right 1. So slope is negative 1. So it'd be 6 times negative 1 minus 1, which should be negative 3/7 is the limit. Okay, and then the last thing you might get is no graph, no table, just a regular function. Plug in negative 1 real quick. So you get 2 times negative 1 is negative 2 plus 2, so that's e to the 0 power. 3 times negative 1 is negative 3. E to the 0 power is 1. 3 times 1 is 3, minus 3. We get a 0 on top. On the bottom, negative 1 squared is 1 times 5. 5 minus 5 is 0. L'Hopital's rule can be used. So we would do derivative of e is itself. I also know I'm going to have times the derivative of the power, which is simply 2. So I'm going to go ahead and take 3 times 2 is 6. E to the 2x plus 2 plus 3 over 10x. And then I'm going to plug in negative 1. Okay, you should get e to the 0 power. Anything to the 0 power is really a 1. So 6 times 1 is 6, plus 3 is 9. So you get negative 9/10 as your answer.